Now, okay. So yesterday's lecture, as I mentioned before to you guys, got screwed up. Didn't work. I mean, the video didn't work. So I'm just going to quickly just sum up, because don't you guys mostly understand polynomials now from yesterday's lecture?
Yeah, we got
most of you.
polynomials.
Right. So what are the different kinds of polynomials you can have? Raise your hand. Okay, Nathan.
Monomial.
Okay.
A binomial.
A monomial. Hang on. Monomial. A binomial.
And a trinomial and a polynomial.
Right. A trinomial. And then anything bigger than that usually is just called a polynomial, even though this is also a polynomial, and this is a polynomial, and this is a polynomial. The weirdest thing, I've never been able to get in my head that a monomial is a polynomial.
Yeah, because
But it doesn't make logical sense. But I think it's because it's grouped. It's like they use the word polynomial as a group, right? And it's everything is encompassed in it, and doesn't make sense. Yeah, go ahead.
Can you like change the L's to look more like L's? The monomiac, the binomiac.
I know I do have this tendency to write my L's to look like a C.
Isn't there a hexanomial?
Polynomial. Well, you know, like I said, all of that makes sense. If you had said that, I kind of know what you're talking about. But it's not usually it's not used, right?
Yes.
So a monomial, an example of a monomial would be anything. First of all, a monomial is going to be anything that's written in this form: a, x to the n, where a is a number and n is a number, but x is an x or a variable, right? So it could be, 3x squared. That would be a monomial. How about 4x to the 0? X to the 0 is 1. Therefore, 4 times 1 is 4. So therefore, 4 is a monomial. 16 is a monomial. Any number is a monomial, right? I could do 1/2. That's fine. 1/2 is a monomial.
As long as it wasn't 1 over x.
It could be 12x, y, z, w, a, b, c to the 4th, right? It could be anything. As long as there's no plus sign or minus sign in there, right? As soon as I put a plus sign in there, or a minus sign, it becomes a binomial. So it'd be like this: x plus 2, or 3x minus 1, or 5x, y, z squared minus 2ab, right? Binomials. There are two terms. One term, two terms. One term, two terms. One term, two terms. Or two monomials. Terms and monomials are basically the same thing. Trinomials. If I have a plus and a minus, or a plus and a plus, or a minus and a minus, right? So that would be like this: x squared. This is really common. You're going to know how to factor these soon, right? X squared plus 3x plus 2. Something like that. You're going to know how to do those and do something really cool stuff with this. Maybe that's what. No, I'll do that another time. Okay, so that's a trinomial. Okay, you can see it in all different ways. You can do, 5xy squared plus 2x y minus 10x. You could see something like that. Polynomial would be 4 terms, right? Or 5 terms, or 6 terms. Okay, so that's pretty straightforward. You guys all remember this from yesterday. How do you know if something is not a polynomial? Do you remember how I decide what does something? So, Indu.
It has a negative exponent.
Yes. Okay. So not. So I'm going to make a little thing. A not polynomial. This is different, right? Not polynomial. This is the things that it cannot be. One, you said exponents.
You can't have a negative exponent.
Okay. Can't have a negative exponent. Negative exponent. This marker is starting to die. Hi.
Hello.
Okay. Hang on. Let me get a different one. Okay. Can't have a negative exponent. So you cannot have 2x to the negative 3. You can't have it. You can't have it and call it a polynomial. It is still a term that we would use. right? There's still stuff I can do mathematically with that. It's just not a polynomial. That's right. You know what I mean? Okay. What else? Somebody else. Landon, you have your hand up. Say it again. Another thing that
you can't have x as the denominator.
yes, it can't, and that's sort of related to this one. Can't have x or variable, right? Variable in the denominator, And that makes sense because think about this. If I wrote this without a negative exponent, what would I have? I'd have 2 over x cubed. So x is in the denominator now, right? So it's not a polynomial. It's not a term of a polynomial. If I saw that in a polynomial, either this or this, I would say, oh, it's not a polynomial.
It's negative.
Kareem.
Yes.
It also can't have a variable as an exponent.
Yes, exactly. That's the third main one. Exactly. So can't have a variable as an exponent. Variable as an exponent. So you cannot have 4 to the
X.
what am I doing? 4 to the x. Yeah, 4 to the x. You can't have 4 to the x. You can't have a variable as an exponent. If you do, you can have it. It's just not a polynomial, right? Just like, a plant, can have
A mouth.
a plant can have, I don't know, what can it
Bird.
I'm trying to think of an example. But like it might not be a tree. It can still have a flower, but it might not be a tree. Or it could have a berry on it, but it might not be a tree. Whereas another tree would have berries. But it's the same thing. It's just a polynomial. Those are things you can't have. It's not called a polynomial if it has those things. So that's all it is. So that's that. So now, can I erase all this? Yes? Please tell me this is still working. Yes, it is. Phew.
I don't like computers because they always have updates. Was that the whole thing?
The whole what?
The whole lecture?
Well, there was more to it. I made a lot of mistakes and I wrote things wrong. Nate corrected me. He and I argued very badly. We were having almost had a fist fight. You missed a lot. It was really cool. I mean, it was awful. So degrees. So now every polynomial has a degree. Okay? And you just have to be sure you know this because you will be asked on NWA, I guarantee you, at least SATs, you'll be asked what's the degree of a polynomial. And so if you had a polynomial 2x to the 8th plus 3x to the 6th minus 10, what would be the degree of this polynomial?
Oh.
Hunter.
8.
It would be 8. You look at the term that has the biggest exponent or the biggest exponents that you would then add together. In this case, you have a 6 or an 8, the 8 wins. It's the biggest. So that is the degree. Okay? So that's your degree. So you would say degree 8. And what if I asked of this? What is my leading coefficient? Leading coefficient.
Wait.
I didn't talk about this yesterday.
10?
My leading coefficient. It's always with the variable that has the largest exponent. So it's related to the degree.
2.
So it's 2, exactly. So my leading coefficient is 2. Even if I wrote it in a weird way, let's say I did this. Let's say I said, we'll do it right underneath here. Let's say I said 4x squared minus 3x to the 8th plus 2x to the 6th negative 16th. Oh, I can't do that. 2x to the 16th, right? So what's the degree of this polynomial? 16. And what is my leading coefficient?
2.
2. Because if I were going to write this in proper order, this is the other thing I didn't mention yesterday, proper order. Proper order.
You order it from biggest exponent to smallest exponent.
Yes, exactly.
That's what I assumed doing the homework class.
Yes, you have to order it from biggest exponent to the next biggest.
Oh, is that
To the
what
next
it's by,
biggest. So it's like going down the stairs, right?
That's what we have to
Right? So this is written wrong. I would have to write this as 2x to the 16th minus 3x to the 8th plus 4x squared. So I'm going starting with the highest exponent, then the next highest, and then the lowest. Right? That's standard proper order. It's called standard form, I believe, for a polynomial. There's a lot of different things that are called standard form, which makes it a little confusing. But for a polynomial, that's standard form. Now, one last example of the degrees. What if I gave you this? 2x squared y cubed z to the third plus 4 x
10.
x to the 6 y z to the third plus 2. What is the degree of that polynomial? Somebody new, somebody different. Somebody Gabe. Are you awake? Are you okay?
Yeah.
Okay. Somebody, I'm sorry. So somebody I haven't called on today. Anybody who knows? Anybody? Adam.
Yeah.
What would be the, just try, just give it a try. What is the, because I'm not sure anybody knows. I mean, some people know probably, because I mentioned it yesterday.
I think he does mention.
So what is the degree of this? So you're going to basically take all the exponents of the variables and you're going to add them together.
Yeah, you just said that.
So 3 plus 3 is 6, plus 2 is 8. 6, what is this? Is that 9?
No, it's no.
There is a hidden, there's a 1 there, right?
Oh yeah.
So that is actually 10. So what is my degree?
10.
10. That is, my degree is 10. And what is my leading coefficient?
4.
4, exactly. Good, awesome. Great, so you guys have that down. Okay, I'm going to erase all this. Is that okay?
Ooh, do we get to do something for that?
Wait, I have one more thing to do.
Oh no.
Can I erase this? I'll take that as a yes.
Gary, how do we find the leading coefficient?
What?
Oh, you just did
How
that.
do we find the leading
Oh, sorry. I'm deaf in one ear, so I'm always looking around to see whose mouth is moving, right? How do you find the leading coefficient? It's always the number in front of the variable or variables that have the largest number of exponents. In other words, wherever you find the degree, that term that has the degree in it, the highest exponent, the number in front of that is the leading coefficient. Coefficient is the number in front of a variable. All right, Saxon would say more than that, but I'm going to keep it simple like that because that's really the way it mostly is. So, like if I had, 16x to the 8th plus 12x to the 4th. My degree is the one that has the largest exponent, which is 8. Where I got, so that the term that has the degree in it of 8, I look at the number in front of the x. That's my leading coefficient. See what I mean?
Yeah.
Because I'm always going to think, the other way to think about it is that I always, if I put it in proper order, I always put the term that has the largest exponent first, right? So then the leading coefficient, if it's written in the right order, is the one in the lead, the 16. Do you see what I'm saying?
Yeah.
Okay? Okay. So the last thing is when does this end? This ends at 37 after. Oh, we're doing great. Okay. This isn't going to take very long. The last thing is adding or subtracting.
Polynomial.
Or subtracting
Polynomials.
polynomials. Okay, so here's what you do. Let's say I gave you this. X squared minus 3x plus 2, parenthesis, plus, parenthesis, 4x squared plus 6x minus 8. Okay.
Oh.
So I have two polynomials, right? They're both trinomials in this case. They're both trinomials, right? This is the question. You don't do anything until you get rid of the parentheses. So this is it. Must get rid of parentheses. Must get rid of parentheses first. Parentheses, right? First. That looks like pissed. But that's not what I meant, right? Get rid of parentheses first, okay? I can't believe. I hope parents aren't watching these videos.
They are.
Okay, so I've got two trinomials. I got to get rid of the parentheses. Do I need these parentheses right here?
No.
Why?
Because there's no negative sign.
There's no negative sign. I don't need the parentheses. Now, if there was a positive 2 there, to get rid of the parentheses, I'd have to distribute, right?
Yeah.
Right? But there is no positive 2, or any kind of a 2. There's no negative. Since there's no negative, I don't need those parentheses. So what I'm going to do, actually I'm going to leave them there. I'm going to just rewrite it down below. I'm going to say x squared minus 3x plus 2. And I don't have any parentheses now, right? Now, do I need these parentheses?
No.
Why?
Because there's a positive.
Because there's a positive sign there, so I don't need these parentheses. So I'm just going to put the plus sign, and then I'm going to write all this. 4x squared plus 6x minus 8. Now, am I done?
No.
What do I have to do?
Add like terms.
Add like terms, right? So what are like terms? Is x squared and minus 3x like terms? No. Is x squared and 4x squared a like term?
Yes.
Yes, because they have the same exponent, right? It's the variable, same exponent. That's the only way they're like terms, right? So I'm going to add everything that's like terms. So I've got 4x squared and 1x squared.
It's 5x squared.
That's 5x squared. So I'm going to write 5x squared, and then I'm going to do this. I'm going to cross out this, and I'm going to cross out
Oh,
this.
that's what I did.
Okay? And then x's. There's a negative 3x and there's a positive 6x. Are those like terms?
Yes.
So what do I do?
Add them.
Positive 3x, right? 6x minus 3x is 3x. Positive 3x. So I write plus 3x. And I cross those out.
Negative 6.
And then I have
Negative
2 minus 8 is negative 6. And I'm done.
Oh, snap.
Piece of cake, right? Piece of cake. All right. One last thing, and then we're done with the lecture. Can I erase?
Hi.
Yeah.
Or should I leave it up? You want me to leave it up? Or is everybody saying you want me to erase it? Or do you want me to leave it up?
Yeah.
You good? I could have just used that same example and just put a negative sign, but I didn't. Oh. So let's say I have 4x to the fourth plus 2x to the third minus 5x plus 7, parenthesis, minus 2x to the fourth, what did I do? Plus 10x cubed minus 4x squared plus 12. All right, end of parenthesis. Okay. First thing is I must get rid of my parentheses first, right? Just remember, pissed. It always works. Pissed. Get rid of my parenthesis first, right? Okay, so do I need these parentheses? No, I don't. So, don't do that. I just rewrite it. 4x to the fourth plus 2x cubed minus 5x plus 7. I don't have any parentheses there. Oh, shoot. There's a minus sign. Do I need this parenthesis?
Yeah.
Yeah, so I want to get rid of it, though. How can I get rid of it?
Erase it.
Erase it. Why didn't I think of that? You would make math so much easier, Amy.
No, right?
I should just let you teach this. That would be so much better. So,
Distributed property.
yeah.
Yeah,
That doesn't give
Technically,
It's a 1 there.
so technically there's a hidden 1 there, -1, right? Are you taking notes, Alex? Okay. So technically there's a hidden -1 there. But I don't need to think of -1 times this. I like to just think of negative times positive, right? Because I know those. Negative times positive is negative. Negative times negative is, that's all you need to know. That's it, right? So this 2x to the 4th is positive, right?
Oh, snap.
So negative times positive is negative. So I'm going to just write negative 2x to the 4th. And all I'm doing, everybody looking? I'm just changing every sign to its opposite sign. That's all. Whenever you multiply by a -1, you just change the sign. So positive 10x cubed becomes negative 10x cubed. Negative 4x squared becomes positive 4x squared. Positive becomes negative 12. All right, now what do I do?
Erase it.
Erase it, right. Yeah. Good, okay. So I'm going to add like terms. So 4x to the 4th minus 2x to the 4th. How many x to the 4th do I have?
10.
Amy, you're on a roll today. Okay, there's 2x to the 4th. 2x to the 4th, right? Yes, and then I'm going to cross those out. Okay, now what? I've got x to the 3rd. Okay, 2x to the 3rd minus 10x to the 3rd. Amy?
Wait, 2x minus
8.
negative 8x.
Okay, negative 8x to the 3rd. Okay, I can cross those out. Now, oh, I have 5x. Do I go here? Or what do I want to look for next?
Erase it.
I want to look for an x squared. That's over here. But there's no x squared here. Oh no, what do I do?
Don't do it.
What is 0? Wait, drop it.
Drop it? What does that mean?
Just go ahead. Problem. Give it to the problem.
Bring it over here?
Yes.
Oh yeah. So there's only
Problem
only one x squared, which is 4x squared. So I'm going to say plus 4x squared. Cross that out. Now I got minus 5x. That's it, right? There's only one of those.
Feed it to the problem.
Minus 5x. Now what's 7 minus 12?
Negative 5. Yes.
All right, we're done. We're done. That's the key, though. That's where so many people mess up. Is when there's a negative sign in front of a parenthesis. I'm going too long, I think. The flags are waving. Okay, that is the end of this lecture, you guys. And it means I don't have to do this in my free time. Oh, you can't even see the fist. That's great. That's awesome.
Well, you said it.
Here, we'll just give them a little. Oh, look, see? Must get rid of parentheses first. You guys don't get me in trouble.